Today, this being a steel's special presentation, I took up this topic. It's more of an industrial use where this particular usage only steel can be adopted. No other construction material is possible for these usages. When you come to material handling structures, you get ores and from the mine the material is taken to either, like if it is a coal, it is taken to a power plant, or if it is imported from port, those ores are taken to the process factories. So broadly it comprises three, you can call it three different structures. One is the material transport structure based on its functions, and then you store the material and also use those structure to retrieve the material, and then take the material to a stacking yard covering with roof sheds. The structural engineering involved here is a little bit, the loadings are quite abnormal, and the challenges are very high. Like you will have intermediate buildings, you need to cross quite a lot of distance. And this is a 60-meter span conveyor gallery. Usually if you see government projects, they will give a specification not to exceed 18 meter and 24 meter. So we, strictly speaking, there is no such constraint. So that's what this is performing more than 15 years. And there is no issue out there. But there is always a clause in spec not to exceed 1820, and you get uneconomical structure because of that. Because the wisdom is you have the height of trestle same or more than less than the span. But such heuristics are known to only practicing engineers, and because of the gap, some of those specifications comes into government documents, and contractors has to stick to it. Here is another material handling structure called bucket elevator, which is the other structure near to it is called silo, where cement or clinker is stored. Many other ores are stored. And this is a jetty, the conveyor supporting structure over a jetty. Yeah, here the clinker is stored in this bunker. Above that you will have a lot of material handling structures installed, loading structures are installed. And morning I heard about a composite structure, and many times in industrial use, the real composite in the sense you use concrete up to some distance, and then where the loadings are high. When the loadings are very high, going for a steel structure sometimes in India it becomes very uneconomical, and then where you really need to have height and span more, go for steel. That is the knowledge we got it in the usage of industrial buildings. This is a wagon loading structure where cement bags are loaded into wagons. So it's about 750 meter. So the earlier days manual loadings were there, nowadays all are automated. So these steel structures help, because here you can't think of any concrete other than precast. Maybe precast concrete can be used, but these days it has become expensive. I had seen them in usage 40 years back or 30 years back. Now all of them are replaced with steel structures. We handled some of the key material handling projects showing it. This is a 17-kilometer pipe conveyor project. This is coming up at Nagpur, transporting coal from 3 mines to the power plants inside near the city. See, this replaces truck transport for a long distance, pollution reduction, accident prevention. So many advantages are there. The pipe conveyors, see, basically standard conveyors, it goes straight and then takes a turn at a transfer tower, whereas pipe conveyor can take a turn and goes up and down. So it's a new technology that has come to transport material, and we could provide a cost-effective structure for them. Like regular standard galleries weighs about 600 to 900 kg per meter, whereas these pipe conveyors, we could bring it down to 200 kg per meter. Even certain profiles we could achieve 150 kg per meter. So for a 17 kilometers long pipe conveyor, the reduction, you can work it out, it will be quite a considerable amount. So these are the key aspects in this project. We have found for the new code provisions to, if you use tubular hollow sections, particularly for compression members, you could get a good economy in it, And another thing is the right configuration of the structure. These are the photographs, the road crossings. And all these conveyors ends in a structure called surge hoppers. All are in steel, then yards. The one over the RCC trestle. Here we used RCC trestle because this is a government project. There are some impractical specs are there. To meet it, we could not put the steel here. So there is a deflection criteria called H by 1000, and which we don't use it in private players, but in government projects this H by 1000 needs to be adhered to, and they say it's a conveyor process requirement. So I ask a question, okay, for a 50-meter tall trestle, you allow 50 mm deflection. So why not the same 50 mm in 10 meter? Why do you insist on H by 1000? So there is a gap between practical, but that particular spec is from mechanical engineer, and that has come into structural specification as well in government projects. So we were forced to go for RCC trestle here. It runs for about, this one stretch is about 7 kilometers and loads into a surge hopper. Goes on like this. In standard conveyor, you will have walkway adjacent to the conveyors for maintenance. Here we go for trolleys. Even the trolleys are designed by us, other than the mechanical system. The second project is what is called RLS system, rapid loading system. This is done for Chettinad Cement by SA, Bangalore. Usually the hopper is placed on the structure, but in this particular building, the hopper needs to be a part of the structure, and you will have the tangential beam, taking up the vertical load and transferring to the horizontal intermittent hoop ring beams, to take the hoop compression. The whole thing acts as one unit. It's about 50-meter high building. So this is how it is finished. It's at Mangalore Terminal. There's the internal view. This is the one which loads the wagons, all these train wagons. You can see they load it on the run, so it's quite a and this is a 128 meter by 270 meter coal stockpile. This is for Tangenco coming up at Odankudi. You can see, of course, these concept-wise they can be adopted for the commercial building also. You can see the tonnage is so low for such a long with no clear space. It's made with the space frame. It will have arches at regular interval and supported with pedestals. We also noted, like such a large span, one has to integrate the supports into the building, into the analysis, into the model, because the deflection of the supports makes some of the member very critical. Because these space frame has failed in 2-3 sites. Most of them won't come out because they are inside the factories. So, and this is one aspect, like PEB structures, they give you reactions and you finish your substructure design. But beyond some span, we have noted like the structure design also needs to take care of the horizontal deflection happening at the base. So we with both the civil and steel together, we do most of the structures, so we know these aspects, but in practice we could see PEB giving separate and the substructure is dealt separate. It works maybe up to some 30-40 meters. Beyond that, one has to integrate the support into the model. So another work, similar kind, 90-meter span. Here, of course, the spec requires spacing to be given, so we made it at 7.5 spacing. In the earlier one, it was about 3.5 arches on the internal side, and the external one is spaced intermittently, so you get a triangulation, and that is also and doubly supported. Here it is single column supported, and when we say this created extra tonnage of so about 20-25 kg per meter square in plan. Extra tonnage happened for this 90 meter compared to 128 meter where we kept the arches reaching up to the foundation. So as I said, by using the tubular section, we could bring in a lot of economy to the conveyor structures. And this is the composite action which I was suggesting. We did this for L&T in the shipbuilding Kattupalli, where a 200-ton crane is sitting on that frame. So when we tried with the steel, the space was not adequate. and we had to go for a composite in structure itself. You do concrete up to some distance, and then the space you make it with steel. Yeah, this is what is called silo bunker, day silo structure. Here the process team wanted totally in steel, but we don't advise it. We always say up to this level where the load is coming, you bring it with the concrete, and the rest you can do it in steel. Right. Yeah. So this is some of our client. Like we also do commercial buildings, but one of the thing which we here specifically I took up is only because in these structures process consultants are involved, and they expect certain requirements, and all this is possible only with steel.